And so in the previous segment, we showed that the continents move around relative to each other, and this was called continental drift, which is not quite right, but we have established that the continents do move relative to each other. Then we also talked about seafloor spreading, and at certain parts of the Earth where the plates are moving away from each other. So that's seafloor spreading. So now we're going to take those two concepts, we're going to put them together and incorporate them into the concept of plate tectonics. So there's three basic ideas for plate tectonics. One, that the Earth's lithosphere is going to be divided up into plates that move relative to each other. So what do we mean by the lithosphere? So that the Earth has a solid inner core, it then had a liquid outer core, it then had an area that was called the mesosphere, which is solid, but yet it could move very, very slowly like a liquid. And then on top of that was a very thin layer called the asthenosphere that was slippery. And then on top of it was a solid layer called the lithosphere. So that the lithosphere is going to ride on top of the asthenosphere. The next thing is that the plates, the lithospheric plates, can either be continental plates, they can be oceanic plates, or they can be both. So they can be a combination of both oceanic and lithosphere, continental. So what can these plates do? So these plates can be pulled apart, these plates can be pushed together, and then the plates can slide past each other. And so depending on what the plates are doing, that's going to create different geological features, which I'll show you in just a moment. So let's look at these lithospheric plates. The Earth's surface is broken up into a bunch of these plates. There's about 12 big ones, and then there's a whole bunch of little ones that go with them. And an example of a really big plate would be the Pacific Plate, which, as you can see, takes up most of the Pacific Ocean. And another really big one would be the Eurasian Plate, which is a combination of Europe and Asia and a little bit of the Atlantic Ocean. The North American Plate consists of the North American continent and then, again, part of the Atlantic Ocean. And when I say the word ocean, I'm not talking about the watery part. I'm talking about the rocks that form the bedrock of the bottoms of those oceans. So those are the various lithospheric plates, and you'll see that on that picture there are some lines and there are some arrows. And you notice that some of the arrows are moving away from each other, some of the arrows are pointing towards each other, some of the arrows are pointing in opposite directions. And so all of those are going to be different kinds of plate boundaries. And at those plate boundaries, you're going to have different kinds of geological features form. So how do we know where the plate boundaries are? Well, in some cases, you can spot them by looking at where the heat is coming up. So remember we talked about the ring of fire? Well, that ring of fire, that area where heat is coming up, is marking a plate boundary. Another way of seeing where plates are located at is looking for mountains. So if you look at for example, the western coast of South America, you got the Andes Mountains. And so that's going to be a plate boundary where two plates are running into each other. And it's going to be causing those mountains to come up. So plate boundaries are going to be normally areas of where you got excessive volcanoes, mountains, earthquakes, And also we need to talk about what's the difference between an active plate and a passive plate. So the western coast of South America, where you've got a oceanic plate going this way, and it's colliding with a continental plate that's going this way, that's going to make what's referred to as an active plate boundary. And so it's active. There's going to be lots of earthquakes and lots of mountain building going on there. Now, on the other hand, let's look at the as far as the plate boundary for North America. So do you remember that it consisted of the North America, and then it also consisted of that part of the oceanic plate that makes up about half of the Atlantic Ocean. Well, that one is going to be called a passive plate boundary. Notice that there's no heavy-duty mountains in North America on the eastern coast, with the exception of the Appalachian Mountains. Well, they don't count because they're basically dead mountains. We'll find out later what caused the Appalachian Mountains. But the idea is that the North American plate is moving away from that spreading center, and so this part of the plate is not running into anything, so it's very passive. There's not a lot of earthquakes associated with it. There's not a lot of mountain building associated with it, so that's called a passive plate boundary. So that's how we locate these edges of these plates. Okay, we're going to take a break, and when we come back, we're going to talk about how do these plates interact with each other.